Hi smart people, Mr. H here. In this video, I'm going to walk you through Aleks 7-3, Similarity and Transformations. Please get logged into your Aleks and open this assignment. We're going to go over question number 1, which pairs of figure are congruent and which pair are similar. Okay, so first of all, we need to know what is congruent. Okay, what do you think the congruent means? Congruent, more often we hear the term equal. Congruent mean equal. Okay, in geometry is mean that same size, a figure that have same size and same shape. Okay, same size and same shape. Now the second term that we need to know is similar. What does it mean similar? Okay, similar mean that they have the same shape, but the size can be different. It can be same size, bigger or smaller, is still a similar. Okay, same shape is already a similar. All right, we're going to look at the first one. I'm sorry, I already did this problem. If you turn the t 90 degree counterclockwise, you will see the t going sideways and then translate it down. So they will be mapped on top of each other perfectly. So they're congruent, similar because they look the same. So yes. This size going to be congruent, yes, because your circle has the same radius, which is 1. And they look similar because they're a circle. All right, the one down below. What do you think about this one? Is this one a congruent or not a congruent? Do they look the same? Do they have same size? Sorry, they don't have same size, so it's not congruent. One more time, congruent means equal. It have to be exactly the same. They are similar, yes or no? I'm not sure if they are similar. Okay, we're going to check if they follow the same ratio. So the width of this one is 1. The width of this one is 3. Okay, so we see that the scale factor is times 3, right? 1 to 3, which means times 3. So the length of this square is 2. If they follow the same ratio, that would be 2 times 3. That will give you 6. Let's see, is that going to be 6? 1, 2, 3, 4, 5, 6. So they follow the same ratio. So yes, they are similar, but not congruent. They're similar because they look the same. They follow the same ratio. Is this one congruent? The answer is no. They don't have same size, same shape. Is this one similar? The answer is also no. If this triangle are similar, they should have the same ratio. Okay, this is 1 box, so this increasing by 2. This is 1, so it should be increasing by 2 instead of 4. They will be similar if the triangle looks like this. Okay, so they do not look the same. All right, sorry, check for the answer. If you think you understand it, go ahead, try, pause the video and try the next one. Otherwise, stay on the video with me for one more problem. Okay. All right, number 2. The first one, is this congruent? The answer is no. They do not look exactly the same. One bigger than the other. Are they similar? They both are circle. The radius of the first circle is 1. Second circle is 2. So yes, they follow the same ratio. They're similar, or basically they look the same. Is this 2 congruent? The answer is yes. They look exactly the same. They look exactly the same because this one, the base is 2 boxes. This base is 2 boxes. This one is 3 boxes. And this sideways 3 boxes. So basically, you turn the triangle 90 degree counterclockwise and then translate it to the bottom left corner. Then you will meet that triangle. So are they similar? The answer is yes. If they are congruent, they have to be similar. Because similar is a small part of the congruent when they have the same shape. doesn't mean they have the same size for similar. How about this one? Are they congruent? The answer is no. They do not look exactly the same. Are they similar? So we check the ratio. This is 2 boxes, and it's increasing by 1, 2, 3, 4, 5, 6. So 2 to 6, which means you time 3, right? 2 times 3 is 6. The bottom box, the base of this figure is through 2 boxes. If they follow the same ratio, 2 times 3 will be 6 boxes. 1, 2, 3, 4, 5, 6. So yes, they follow the same ratio. They are similar. They look the same, one of them bigger than the other. This one. Is this one congruent? The answer is no. They do not look exactly the same. Are they similar? The answer is also no, because the width increasing by 2, and this one is a square, so it should be the same size for length and width. All right. If you got this, go ahead, do your Aleks. Pause the video and do your Aleks. Otherwise, stay with me on one more problem. Okay, this time I will go faster because I believe we already understand the concept. Okay, you can pause the video and try this one by yourself before I give you the answer. Okay, the first one is going to be congruent because they look exactly the same. Since they're congruent, they will be similar. The second one, they're not congruent because they do not look exactly the same. Are they similar? So the ratio is 1, 2. 1, 2, 3, 4, 5, 6. So it's increasing by 3. The base of the triangle increasing by 1. So, the base of the small triangle is 1 box. So times 3, that will give you 3 boxes. So they are follow the same ratio. So yes, they're similar. The second one, are they congruent? The answer is no. Do they look the same? The answer is no. 2 square look exactly the same. They're congruent, mean they're also similar. All right, we will heading to number 4. Okay, pause the video. Please do not watch number 4 until you finish problem 1 through 3 on your Aleks before watching number 4. All right, number 4. Each part dilate the solid figure exactly into the dash figure. If it is not possible, click not possible. Okay, so this is kind of straightforward. All you have to do is slide the slider. The blue box supposed to lie on top of the dotted line. They do not line up correctly, so this is not possible. If you move this, you see that the blue box will line on the dotted box. At the scale half, or 0.5, is between 0 and 1. So it would mean the shape is reduced by half. All right, that's it for that. Easy. Check. Number 5. Excuse me. Same thing, move the slider. If they line up correctly, that is the answer. Yes, so they both have the answer here. Check. All you have to do is slide the slider. All right. Go ahead, do number 4 and 5 on your screen before you watch number 6. Yeah, pause the video. All right. I hope you finished 4 and 5. Now here we go, number 6. For the figure, do a dilation center at the origin with the scale factor of 4. Then answer each part. So scale factor of 4. All you have to do is move this slider to 4. So they will give you the figure, which is the scale factor of 4. Shortest side length of original figure, how many units? shortest side length of the original figure. So which means it's the one from the beginning. So that is one box. The answer is 1. The solid side length of the final figure, so the one that we just moved, is 1, 2, 3, 4. That is the shorter size, is 4 units. And it makes sense because scale factor of 4, 1 times 4 is 4. So part B, fill in the blank to make true statement. The shortest side length of the final figure right here, is blank times the shortest side length of the original figure. Original figure was 1. To get 4, you're going to times 4. 1 times 4 is 4. True or false, a dilation with a positive scale factor greater than 1 give the final figure smaller than the original figure. So if the scale factor greater than 1, in this case 4, which is greater than 1, did we have the figure smaller than the original? The answer is false statement. Okay, if it's bigger than 1, you make it larger that many times. So this is 4 times bigger for this example. True or false, the original figure and the final figure are similar. True. With the dilation, the shape will similar. You just make it bigger, smaller, but shape should stay the same. That's it. Check. All right, number 7. Pen clear. All right, do the figure dilation center at the origin with the scale factor of 1/2. So all you need to do is move this to the half. So it will be between 0 and 1. You see that the figure gets smaller. The longest side length of a regional figure, so our regional figure is this guy right here, is 1, 2, 3, 4, 5, 6, 7, 8. That is the longest size is 8 units. The longest side length of the final figure, so the one that we get after move the slider, is 1, 2, 3, 4. It's only 4. Remember the scale factor is 1/2, which means it reduced by half. So half of 8 is 4. Fill in the blank to make a true statement. The longest side length of the final figure equal to something times the side length of original figure. So original was 8, is go down to 4 because you divide by 2, or a different way to say it is times 1/2. So times 1/2 is the answer. Dilation with positive scale factor less than 1 give you a figure larger than the original figure. False. Less than 1 is 1/2, is reduce the shape, reduce the figure by half. The original figure and the final figure are not similar. False. Dilation always give you similar figure. Check. Raise. All right, number 8. Okay, same thing. Scale factor is 3. The shortest side length of a regional figure, so which is down here, which is 2. The shortest side length of the final figure, which is 1, 2, 3, 4, 5, 6. 6 units. Fill in the blank to make the true statement. The shortest side length of the final figure, equal to something times the shortest side length of a regional figure. So 2 to get 6, you times 3. The scale factor indicate that is 3. A dilation with a positive scale factor greater than 1 will give the final figure larger than the original figure. True. Greater than 1, you're going to get the bigger figure. The original figure and the final figure are not similar. False. They have to be. They have to be similar. Okay. Now, guys, pause the video. Make sure you get up to problem 9 or problem 8 until you before you watch problem 9. Problem 9. Answer the question about figure A and figure B below. Okay. So to map from A to B, oh, sorry, I should read the question. Which sequences of transformation will map figure A onto figure B exactly and choose all that apply A to B? So translate figure A to the left A units. Figure A translate to the left A units. Okay, so I'm going to pick the corner right here. 1, 2, 3, 4, 5, 6, 7, 8. And then dilate the result scale factor by 1/2. So you make it smaller by half. We will have something look like this. Okay, it's not even close to that one. So the first one is wrong. Okay, second one, dilate figure 8 and scale factor 1/2. Center at the origins, and then reflect the results over the x-axis. So dilate it by 1/2 and reflects across the x-axis. So everything reduced by half, which means that this one is 2 units away from that. Let's go down to 1. And the side length is 1, 2, 3, 4, 5, 6 is reduced to 3. The height of the trapezoid is 4, so it's reduced to 2. This is 2 will reduce to 1. You're going to look like this. Okay, and they say reflects across the x-axis. Yes, so when you flip it over, they will map to figure B. So correct answer is second option. Is figure A and figure B similar? Do they look the same? The answer is yes. They go through a certain transformation, but they do look the same. Yes, that's it. Check. All right, last problem, problem number 10. Pen, clear. All right, which sequence of transformation will map figure A to figure B exactly? Choose all that apply. Translate figure 8 A unit to the left A unit, and then dilate the result scale factor of 1/2 at the origin. Okay, so A unit to the left. 1, 2, 3, 4, 5, 6, 7, 8. Okay, if that's the case, then you're going to see something like this. 4, yes. Okay, now scale it down by 2, by 1/2. So this will 1, 2, 3, 4 is go down 1, 2, correct? And this is 2 boxes go down to 1. So that reflection, that description is correct. Translate figure 8 A unit to the left, and then dilate the result scale factor of 1/2. Is the figure similar? The answer is yes, they are. All right, that's it. Check. Oh, something not right. Are they similar? Yes, they are similar. So I guess let's see what is the other option that we can do. Partial, the answer is incorrect. Okay, let's clear this, erase this part. Is that reduced by half? 1, 2, 3, 4, 5, 6 is reduced to 3. 1, 2, 3, 4 is reduced by 2, and this is reduced by 1. Let's see, is there any other better explanation? A unit to the left, delete the result. Scale factor will have center of the origin. Yeah, I don't see any problem with that. Dilation figure A with the scale factor of 1/2, center at the origin, and then translate the result. Uh, Dilate the figure A with the scale factor of 1/2. So this is two boxes, go down to one. This will be four boxes away, that will be two. Two boxes down, that will be one. 1, 2, 3, 4, 5, 6. 6 is reduced to 3. Translate 4 units to the left. 1, 2, 3, 4. That also looks right. Okay. Translate figure 8, a unit to the left. Right, and then dilate the result with scale factor of 1/2. Center at the origin. I don't think anything wrong with that. The first one is correct. The second one is also correct. Dilate figure A with the scale of 1/2 as center of the origin, and then reflect the result over the x-axis. Cannot be reflected over the x-axis because it's gonna look opposite of what we see in here. Dilate the figure A, scale factor 1/2, center of the origin, and then reflects over the y-axis. So x-axis is going up, y-axis is going the other way, but it's opposite. That's it. I guess this one has two answers. Let's try it. Yep, that's correct. So there's two possible answers here for this interesting for this problem. So it's possible to have more than one correct answer. Okay, I was so eager with I'm so excited with the first correct answer, and then it just stopped. Make sure you read through all the description. They have more than one correct answer. All right, thank you everyone for watching, and see you tomorrow.